All right, for number 7, we have an object launched horizontally from a height of 30 meters above the ground with a speed of 20 meters per second, and we want to determine when it's going to hit the ground, the horizontal distance it travels, and the speed with which it hits the ground. And just to be clear, I think I want to draw a picture of this because I saw some confusion when people were working this out in class. So it kind of works like this. Picture this as a cliff, and we launch the object horizontally, and it has an initial speed of 20 meters per second. And a couple of things. It says the height is 30, and if we look at our vertical equations, we're using suvat in the vertical direction, and in the horizontal we're using the constant velocity equation that we got way back in the day from doing the lab with the buggies at the beginning of the school year. So what that means is that S is 30 meters. That's the height right here. Now the other thing is that we have a horizontal range or distance that it covers from the base of the cliff, and that's right here, and that's an unknown quantity, and x naught is always 0. So now let's fill in what we have. So the horizontal x naught is 0. This is unknown. This is 20 meters per second, and the time is unknown. And just to be clear, this is a fully horizontal. It says launched horizontally, and here's the speed. There was a little confusion about why this is only horizontal, and that's because it's stated very, very carefully in the problem. Now let's talk about the vertical direction. S is 30. Once again, our initial velocity vertically is non-existent. There's just none there at all, which is why u is 0. V is unknown. The acceleration is the acceleration because of falling, so that's going to be gravitational acceleration. A lot of people just say the word gravity as a shorthand, but I want to be really clear that this is the acceleration due to gravity, which is 10 meters per second squared, and t is our unknown. So for part A, we want the time at which it'll hit the ground. So we use s equals 1/2 at squared plus u times t, and that's going to be 30 equals 1/2 times 10 times t squared plus 0. I know a lot of students will just say 30 equals 5t squared when they simplify. This is going to be 30 equals 5 times t squared. A lot of students skip straight to this step here, which is fine. I can live with that, as long as you know what you're doing. And we'll get that time squared is 6 seconds. And so that's going to give us a time of 2.45 when we take the square root of both sides. So that's the time. Now for part B, that's seconds right there. So let's just be clear that this is 2.45. And to be clear, we're launching from here and hitting the ground, so we calculated a time for that. So what that means is that there's no need to double anything. We're not going up and then down like in question number 8, which you've done a version of. We're just going straight to the ground. So for part B, we want to get the horizontal distance traveled. So let's put in our numbers. That's going to be x equals 2.45 for the time. And, I just want to be absolutely clear on what I'm doing. So let me just I want to get the order of this right, because I know I'm multiplying when I'm multiplying, but I want to make sure that you can be really clear on what I'm putting in for each number. So just to be clear, once again, I'm going to put v naught in the x direction as 20, and this is times 2.45. And so when I simplify that out, that's going to end up being 20 times 2.45, so that's going to be 49.0 meters when I simplify that out. Now for part C, we want the speed. Let's be really clear. That's actually how fast the object is going. So let's be clear that v naught in the x direction is 20 meters per second. That's given in the problem. Now let's get vy, and that's going to be equal a times t plus u, or rather I can just say v equals at plus u. So let's solve for v. So v is going to equal 10 times 2.45. And so that ends up giving me 24.5 meters per second. Now the total speed is actually going to be, it's the length of the velocity vector, which is made up of v naught x and v, which is the y direction speed. So that's going to be 20 squared plus 24.5 squared, all under a square root, which is going to give us 28.6 meters per second for the speed. All right, that's question number 7.